Okay, so we're going to be finding slope and graphing lines on 2-1. The formula for finding the slope of 2 points, it's on your formula chart. It says m equals y2 minus y1 over x2 minus x1. Remember, slope is rise over run, so that's the reason why y's are on top, because you're rising, which is your y-axis, and then running, which is your x-axis there. Okay, so we're going to find the slope of the given points. So first, remember on a ordered pair, x comes first, so x and y. So plugging into the formula, it says, notice in the formula y2 minus y1, but it really doesn't matter, just as long as if you start with the second y, you start with the second x, and then vice versa. So if you start with the first y, you need to make sure you start with the first x. Okay, so it really doesn't matter on that. Okay, so find the slope. We're going to have our y value. I'm going to start with the first one. So the y value is 2 minus the second y value, which is 8, over negative 6. We have to start with that first x, since we started with the first y, minus 4. So that would equal negative 6 over a negative 10. Okay, so make sure that you reduce. So that would give you 3 over 5. And since we have a negative divided by negative, that would give me a positive. Okay, so a positive 3/5 would be the slope. Okay, same thing on number 2. We're finding the slope of 2 points. So first coordinate is your x, second one is your y. So looking at your formula, we'll take change in y on the top. So we're subtracting the y values. I'll start with the first y, so negative 3. On your formula, you're subtracting. So that would be minus, and then we're plugging in that second y value, which is a negative 3. Okay, so denominator, we're subtracting the x's. So start with the first x, 2 minus second x, which is a negative 1. Now, anytime that you're subtracting a negative, that will make it a plus there. So on top, negative 3 plus 3 would be 0. 2 plus 1 would give you 3. So 0 divided by any number is 0. So slope would equal 0 for those 2 points. Okay, so same thing on 3. Still find the slope of the 2 points. So first y value is negative 3 minus your second y value, which is 6, over your first x, 2 minus your second x, which is 2. So on top, you would get negative 9 over 0. Now, if you were to type that in the calculator, it's going to say error because that's undefined. You cannot divide by a 0. Okay, so that's undefined. So therefore, there is no slope. So there's a difference between 0 slope and no slope. 0 slope, it's a number. It's 0 slope. Okay, we're going to talk about what that looks like in just a few minutes. And then also your no slope, you have a 0 in the denominator, which you cannot divide by a 0. Okay. All right, so now let's talk about what the lines will look like if we see a graph, so we can determine if it's a positive slope, negative slope, or 0 undefined. Okay, so on a positive slope, you're always reading a graph from left to right, just like you read words. Okay, so positive slope should be increasing from left to right. So that's what a positive slope line would look like. A negative slope would be decreasing from left to right. 0 slope, which is like number 2 that we just looked at, when you have 0 slope, your line will be a horizontal line. And then undefined, which is the same thing as no slope, that will be a vertical line. Okay, so anytime that you have a 0 slope, a horizontal line will cross through the y-axis. So your equation will always look like y equals whatever that y-intercept is. Okay? When you have a vertical line that will cross through the x-axis, so that equation will always look like x equals whatever your x value is. Okay? So on this one you won't have an x, on this one you won't have a y. So there's the difference between your 0 slope and your undefined slope. Okay, so moving on, parallel lines have slopes that are the same or equal. And then perpendicular lines have slopes that are negative reciprocals. Okay, so what the negative reciprocal means is if it's negative, that means you're going to take the opposite sign. Okay, so the negative means just change the sign. Reciprocal means you flip the fraction. So an example of that would be if we have a negative 1/2. Perpendicular to that, the slope would be positive 2/1, which would give you 2. So you change the sign and then you flip the fraction. Okay? All right, so remembering parallel lines are lines that never intersect. Okay, so parallel lines, if you were to stack it on top of each other, move it, it's going to give you that same slope. Okay? Remember that perpendicular lines, they cross and form a 90-degree angle. Okay, so anytime you have perpendicular lines, they'll have negative reciprocal slopes. All right, so knowing that information, we're going to determine whether each of the following lines are parallel, perpendicular, or neither without graphing them. Okay, so what we just talked about was the slopes and what their slopes will be if they're parallel and perpendicular. So what we're going to do is we're going to find the slopes of line 1 and line 2. Okay, so slope of line 1, we are subtracting the y value, so 1 minus 2, divided by the x value, so 4 minus 7. So that would give me negative 1 over a negative 3. Okay, a negative divided by negative is a positive, so that would be a positive 1/3 for slope of line 1. Line 2, find the slope of those 2 points. Negative 2 minus 1, changing 1 on top. X value is 1 minus 0, so that would be negative 3/1, which would equal negative 3. Okay, so now once we find the slope of the 2 lines, we're going to compare the 2 slopes. Notice this slope is 1/3, this slope is negative 3. So are they the same? No, they're not the same. So we know that they're not parallel. If you notice, this one's positive, this one's negative. If you flip, take the reciprocal 1/3, you get 3. Okay, 3/1, which is 3. So these 2 lines would be perpendicular. You can write it out or use the symbol. So perpendicular lines, okay, without graphing it. Okay, so looking at 5, we're going to do the same thing. So we have 2 lines. We're going to find the slope of each one, and then we'll compare the 2 slopes. Might help you to label each ordered pair, so that way you're not subtracting a y with an x. Okay, always subtract the y's and then subtract the x's. So find the slope. You have 1 minus a negative 13 divided by 3 minus a negative 4. So remember we talked about on the front, when you subtract the negative, it changes it to plus. So that would be 14. The bottom it also becomes plus, so that would be 7. 14 divided by 7 would equal 2. Line 2, negative 8 minus 5 divided by negative 1 minus 6. So we would have negative 13 over negative 7, which would equal positive 13 over 7. Okay, so now let's compare. So notice on line 1, our slope is 2. Line 2, our slope is 13 over 7. Okay, so we know those are not the same, so we know they're not going to be parallel. Negative reciprocals mean you change the sign and then you flip it. So notice they're both positive and they're not reciprocals of each other. Okay, so we would write neither here. So they would not be parallel nor perpendicular. Okay. All right, last one on this type of example. So line 1. We have 9 minus 36 divided by negative 1 minus 8. We have negative 27 on top over a negative 9. when you divide that, that would give you a positive 3 for the slope. Line 2, we have negative 8 minus 13 over 2 minus 9. So that would be negative 21 on top over a negative 7. When you divide that, that would equal 3. So make sure when you're comparing the slopes that you wait until after you have reduced, because these two do not look the same. Okay? But after you reduce it, notice they are the same. And remember from the front, if two lines are parallel, they have the same slopes. So they're the same. So you can draw two parallel lines for the symbol or plot it out. So they're parallel. Okay, so now we're going to take a look at some graphs. So there's two forms that you need to know whenever you're talking about lines, which are linear, okay? The linear slope-intercept form is y equals mx plus b. M represents the slope. And we were just writing m's on all of those problems, so that's the slope. And then your b will represent the y-intercept. Okay, the standard linear form is ax plus by equals c. That means that your x and your y will be on the same side of the equation. Your constant will be on the other side. Okay, so those are the two different forms that you can see on linear. Okay. All right, so it says graph the lines using slope-intercept method. Remember slope-intercept form, y equals mx plus b. So first you need to check to see if the equation's in that form. So notice we have y by itself, we have our x and our constant on the other side. So that's slope-intercept form. So we don't need to do anything to it. All we need to do is find the m and the b. So m is your number in front of x, or multiply by x, so that would be a negative 1 over 2. Now that negative you either need to put with the 1 or the 2. Okay, so either of those, doesn't matter which one you put it with, but it doesn't need to be with both because then that would make it positive, and it's negative. Okay, so there's our slope. B represents the y-intercept, which means it's where it crosses the y-axis, and that number would be 2. When you're graphing using y equals mx plus b, you will begin with b, the y-intercept. So here's your x-axis, here's your y-axis. You begin with 2, so 2 on the y-axis would be your first point. Here's your b. From there, we're using our slope to find the other points. So notice I have a negative 1 on top. Remember, slope is rise over run. So we're talking about the y's and then over the x's, okay? So negative 1 on top means we would need to go down, and positive 2 on the bottom means we need to go to the right. So we would need to go down 1, right 2. There would be your next point. Down 1, right 2, next point. You can continue with that. To get the other half of your line, you would do the opposite. So up 1, left 2, up 1, left 2, and then you will connect your points. Now, on your line, you need to put arrows because it's continuous. We could keep plotting points if our graph was larger, okay? All right, so anytime you're graphing linear, you should see a line. You can check the direction of your line when you finish by looking at your slope. Notice it was negative. Remember we talked about negative slopes decrease from left to right. So you can check the direction of your line. Okay, so now notice on 8. 8 is not in slope-intercept form. We want it to be in y equals mx plus b form, which means we want y by itself. So we will have to do that before we can find the m and the b. So we're going to have to add 3x to both sides. Notice 24 plus 3x, we're not able to add those. So I like to write the x term first, 3x plus 24. Then we'll need to get rid of the 4. So we're going to divide every term by 4. So you have y equals 3/4 x plus 6. Now notice y is by itself. Now we can find the m and the b. So m is your slope, which is multiplied by x. So 3/4. Your y-intercept would be 6, your b. Remember, you begin with b. So it's going to cross the y-axis at positive 6. 1, 2, 3, 4, 5, 6. And then we're going to use the slope from there to find the other points. The slope is positive 3 over positive 4. Remember, rise over run. So we're going to have to go up 3 and to the right 4. Notice that's the only point we're able to do that way. But remember, you can do the opposite to find the other half of the graph. So I'm going to do the opposite and go down 3, left 4. And then you can connect your points. Arrows at both ends because it's continuous. We can keep plotting points. Okay, another method that we're going to talk about is graphing lines using the intercept method. This intercept method, the best time to use this method is when your linear equation is in standard form. Doesn't really work out whenever you're using or whenever it's already in slope intercept. So the intercept method, you're going to be finding the x and the y-intercepts. Okay? All right, so notice number 9, it's in standard form. Okay? That's what form we want it in when we're using the intercept method. Okay, so x-intercept. Anytime you have an x-intercept, no matter where it is, your y value will always be 0. Okay? So I'm going to put y equals 0 here. If we know that y is 0, when you're writing your equation, you can replace y with 0. And notice that's just going to cancel out. So basically, you can cover up your y, and then you would be solving for x. So you would divide by 3. So x would equal 5, and you have your x-intercept. Okay? You can write that as an ordered pair. We know x is 5, y is 0. And there's one of our points. Now I'm going to find the y-intercept by using this intercept method. Okay? So now notice we're going to have to find where it's going to cross the y-axis. Anytime you have a y-intercept, your x value will be 0. So knowing that, you're writing your equation, replace x with 0. And notice that will just cancel because that'll give me 0 there. So I can just cover up that x term, and then I'm just going to solve for y. So I'm going to subtract 5. So y would equal 3. X is 0, y is 3. So that would be the ordered pair. Crosses a y at 3. Now, we don't know the slope of this, but we could find the slope by using those 2 points that we have on our graph. Okay, so I'm just going to connect them. You could find other points by finding the slope of those 2 and then continue with that slope to find the others. Okay, last one. Notice it's in standard form. We still want to use the intercept method. So remember x-intercept, y value 0. So write your equation, y is 0. You can just cover that y up because it's gone. It's just a 0. Divide by 12 to find x. Reduce that to 4/3. The point would be 4/3 0. So 4/3 in fraction or in decimal is 1 1/2 or 1 1/3. So 1.3 repeating, so that would be in between 1 and 2 on the x-axis. And then to find the y-intercept, remember your x is 0. You want to find y. I can just cover up that x, solve for y, so divide by 8, and y would equal 2. So that point would be 0, 2. Crosses the y at 2, 0. Connect your points. Again, draw arrows because it's continuous. We could keep plotting points if we found the slope of those 2 points. okay? All right, so that's graphing linear equations.